The preprocessor provides a powerful and flexible macro system. Here I have a working copy of working.cpp from chapter 3 of the exercise files. We've seen macros that look like this, and I can take that value over here and I can say printf value is %d macro. And when I build and run, you see it says the value is 1. So this is a constant-like macro, and oftentimes it's just called a constant. But macros are actually quite a bit more powerful than this. You can give them parameters. So I can say a comma b like that in the macro definition, and then in the expansion I can say a times b. And declare a couple of variables here, a equals 5, ib equals 7. And then I can come over here and I can say macro ia comma ib, and when I build and run, you see we get the product of 5 and 7, which is 35. So what's happening here is that this macro expansion is taking the parameters and actually expanding those parameters. In other words, this result will be replaced with the text ia, in parentheses, ia times ib, like that. And we build and run, you see we get exactly the same result. So this macro is exactly the same as if we typed that text in our source code. And of course, the macro expansion happens before the compiler ever sees this in the preprocessor. So when it sees this A, this text here gets replaced with whatever the value is of A, and this text here gets replaced with whatever the value is of B. One other important caveat here, you cannot put any space between the name of the macro and the opening parentheses. If I put in space here and try to build and run, you'll notice that we get an error because that's no longer parameters. Now we have a macro that simply expands to all of this text. And that's why we see this particular error. Use of undeclared identifier A, and you'll see we have one there also for B. So without the space there, you always need to have that opening parentheses right next to the text. This is actually a common source of bugs. And there we have it. It does what it's intended to do. Now, any valid code is allowed on the right-hand side because remember, this is just text expansion. So I can say A greater than B question mark A colon B, and I'll get the max. I'll actually rename this macro to max and come over here and rename it to max. And now when I build and run, we get 7 because 7 is greater than 5. And if I change this here, we get 47 because 47 is greater than 7. Now, think about what happens when various expressions are used as parameters. This is the problem with macros. It's important to look at this carefully. Remember, this is expanded to text. So if we have expressions in A and B, even though in a function call, those expressions would be resolved before they're actually passed to the function, that's not the case in the case of a macro. This is text expansion, and it happens before the compiler ever sees it. So the potential for side effects is actually very, very real. I'll show you some examples of this in the next lesson, but for now understand that the use of function-like macros is very common, especially in C. And in fact, the preprocessor was designed to do this. For many uses, though, C++ templates are a superior solution. For some uses, parameterized macros work great, but generally speaking, templates are recommended over parameterized macros. Templates will be covered later in the course, and in the next lesson, I'll give you some examples of the kinds of problems you may run into with parameterized macros.